In this video, you will get introduced to Pandas package, one of the most powerful Python packages for data analysis, and we'll begin by data structures, which are series and data frames. Let's begin with series. To create series, we have to import Pandas, and Numpy will need to use it. We will name it Pandas as PD, and to create series, we have to type the series name equals and use Pandas series function by passing list-like structures to series. We have also other options to create series, and we use here just the most common. So let's run the code to see what we have created. You see here a data structure with row labels and column name. It has a single dimension. Column name is 0. Let's create a data frame. Data frame is two-dimensional data structure. It has rows and columns. So let's create row labels, which in our case are dates. To create sequence of dates, we use dateRange function. So we have to specify the start date and the number of periods here. So we want it to create from January 1, 2020 and for 7 days. Let's see the dates variable here. Let's specify the column names. We create col names variable for this purpose. So we just name columns simple from col1 and to consecutive number of columns. So let's create 4 columns here. Column names should be strings. To create a data frame, we need to use Pandas Dataframe function, of course, by writing pd.dataframe. And then we pass the data. For example, here we create just Numpy random array 7 by 4, which is 7 rows by 4 columns. And specify the index by typing the index equals dates and then columns equals column names. Let's run the code to see the result. So you see here row labels are dates and column labels are the strings we have specified, and inside are the random numbers we have generated. So let's see the methods to view the data frame data. Let's type the data frame name in our console to get what we have created. So this is the data frame we have created. To view, for example, top rows of the data frame, we use the data frame name .head function and we specify the number of rows we want to see. So here you see the top 2 rows. If you want to see the bottom rows, we use tail function and we can also pass the number of rows we want to see. This is the bottom part of our data frame. Describe function is very useful function. It shows the characteristics of data frame: minimum, maximum, mean, standard deviation, percentiles. It's a very useful function. To sort the data frame values, we use sort values function. We also specify by which columns we want to sort. Here by default it sorts ascending. If we do not want it to sort ascending, we specify the ascending argument passing a false value to it. So here you will see the column 1 has a descending sort. You can also sort by index by using sort index function, which will not describe here. To view the column, single column, you just type dataframe name dot column name. You can also, there is another way to see the column values by passing string name of the column into square brackets. So let's slice the dataframe data. There are two main ways to slice the data: slicing by labels and slicing by positions. Slicing by labels uses row names and column names. So here we create sliced label new data frame by slicing our my data frame. We use here log function. We type dataframe name dot log and specify row labels and column labels in square brackets. So here we want to get the value that has a row label 2020 January 3 and column label column 1. So here you see that's a single value. Let's get a data frame. So for that purpose we have to specify several row labels and or several column names. So here we want from January 3 to January 7, and also we want several columns here. So let's run the code, and remember that column names had to be in square brackets if you use multiple columns. This is a data frame. You see we have sliced two columns and we have got from January 3 to January 7 data. Our initial data frame was from January 1. So let's slice by position. Here we use the ilog function. So we type the data frame name dot ilog function, and in square brackets we specify the position of the rows and position of the columns. Position starts with zeros and ends with the length of the rows and columns respectively. So let's see our slice by position. So we have sliced rows from 1 to 3 and columns from 0 to 1. The ending value, it does not include the ending value for the position. This section is about filtering data and handling missing values. So imagine a situation when you want to filter data frame values based on a condition. So you can specify that task in this way. You type the data frame name, square brackets, and inside you specify the Boolean expression. So here we want our column 1 values to be greater than 0. You see what we have got. We have got only 2 rows here. We can also specify like we want all the data frame values to be greater than 0. Then we'll get all the data frame, and the values that are not satisfying the condition will have NaN values, not a number. We can get the same results by specifying column name in square brackets and inside a string quotes. If you want to set For example, data frame values. For example, you want to change the number under January 2 and column 1. You just type the log expression, my data frame.log and row label, column label, and equals the value you want. Here we want the January 2 and column 1 value to be NaN, not a number. You see here we have got the result. It's not a number. If we want to check which values in our data frame have NA, we just use pd.isNA function and pass data frame as an argument. If we want to handle the NA values, we want to drop rows that have NA, we just use drop NA function. Here we have not specified the string quote. That's why compiler interpreter had returned an error. So you see here we dropped the value January 2 row. You see here the rows begin with January 1 and then go to January 3. We have dropped January 2 row as it contained NA. You see here, but the initial data frame has not been affected. It has returned just the copy of the data frame. We can also fill NA values by the values we specify. We just use here fill NA function and pass the value we want to replace the NA. You see here the January 2 and column 1 value has a 5 million number. Before it had NA, not number value. We can use functions to aggregate the data frame data. Here we have used the sum function. It by default it uses the axis 0. That is, it gets the sums by rows. If we pass as an argument axis equals 1, it will apply sum function by columns. You see here our initial data frame. Apply function is a very useful function. It applies the function you have supplied to it to all the values of the data frame. Here we used Numpy absolute function on our data frame values, which converted all the negative values into positive. We can also pass lambda functions to apply function of the pandas. Here we specify lambda x and then colon and then specify what the result we want to get. Here we want our data frame values to be multiplied by 10. Let's do data frame concatenation, which is merging two or more data frames together. For that purpose, let's create second sliced data frame from our initial my data frame. Here we specify the row labels and we have column labels. For simplicity, we will assume that our two data frames have the same columns. So you see our slice label 2 and slice label variables. And we want them to be concatenated vertically, that is by axis 0. It is assumed by default in pandas that you will concatenate vertically, which is by axis 0. So we use pdconcat function and pass two data frames in square brackets. We can also specify the axis, which is here by default 0. So you see here we have concatenated vertically. That is, we have put these data frames together vertically. We can also put them horizontally by specifying axis equals 1. Let's move on to grouping by function. So let's create column groups in our initial data frame, which is like will be used for grouping the values of the data frame. So you see we have we are going to specify the labels for the grouping. We just randomly put group 1 and group 2 on our 7 rows. So let's see what we have got. My data frame had an additional column with grouping labels. And let's group by the values using this groups label. So we create grouped result data frame equals my data frame dot group by, and pass the column by which we want to group by. And then we specify the function that should be used when grouping the variables. So you see here we have grouped by groups column and merged the values using some function. You see, this is the initial data frame. That was our grouped data frame. So let's group by multiple columns. First of all, you remember that dates were our index. Let's reset the index to make the index separate column here. You see, under index column we've got the dates. And then let's rename the columns, because when we reset the index, our index has got a column name index. We want it to have a name date. So we can rename columns by specifying data frame name dot columns and equals the list of new column names. You see, we've changed the column names. And let's specify in square brackets also to be the data frame to be grouped by the date column. So now we are going to group by date and groups columns. You see here it has grouped by, but it would be convenient if the group labels will be in columns like in pivot and dates will be in rows. So you see here we have multi-index for grouped result. First index is dates and the next index is groups. We can create a pivot-like data frame by using onStack function. So if we specify onStack, we get the group labels in columns and date labels in rows. It's like a pivot style. We can also fill NA numbers, as we have learned, with zeros. You see here? There are also very interesting functions for operations with time series and plots. Let's see our initial data frame. my data frame by typing my data frame in the console. You see our date column is a separate column and not in the index. For time series functions, we need date column to be in index. So we use the setIndex function and pass the date column as an argument. Let's see the result. So we have the date column in the index. One of the time series functions is called resampling. For example, here we have a daily data. If we want to get more frequency data like hourly data or less frequency data such as weekly data, we use resample function. Here we upsample the data, that is, we create weekly data from daily data, and we aggregate all this daily data into weekly data using the sum function. You can use any function you like. So here from January 1 to January 7 we have 2 weeks. 1 week ending on 5th of January and the second one ending on the 12th of January. And everything in between has been summed. We can create plots by using plot function, dataframe name dot plot in brackets. Here you see we've got a plain plot and all the column values are converted into line plots. We can also integrate Matplotlib with Pandas. Here, for example, if we want to change the style of the plot, we just import Matplotlib and use matplotlib.style.use and specify the style name. In my previous videos, I've showed the multiple styles that are available. We will use here the ggplot plotting style. You can also integrate the Matplotlib commands that we have learned in previous video with the pandas plots. So here in below we'll specify the plotting command again. We just type the data frame name and dot plot. You can also specify multiple arguments inside plot function. Let's run the code to see the result. Here you see the ggplot style plot, which change our initial plain plot. If we want to specify the title, we can specify inside the plot function by typing title equals and the title name in string. Here you see the my random variables title. We can convert single plot into multiple plots called subplots by typing subplots equals true. Here we see the plots in vertical order. We can also change the layout. For example, if we want 2 by 2 subplots, we specify layout equals and in brackets 2, comma and 2. We can change the figure size. Of course, we can also change the figure size manually, but we can also supply the plot function the fig size. Here you see the increased fig size here. Let's turn to importing data from Microsoft Excel and exporting to it. So to import data from Excel, first of all, you need to specify the Excel file object in Pandas. So you create a Pandas Excel file and pass a link to your file, and pay attention here that we use slashes and not the backslashes for the file address. File address should be in string format. So we have created XLS Excel file object, and by next line we read this file object. So we use read Excel function and pass the Excel file we have created and specify the sheet name. When we run the code, we get the data frame of our Excel table. Let's see our Excel table. Here is the Excel table we wanted to import. So it had automatically created data frame with all the columns in the Excel file. Let's export the data to Excel. So here we have our initial data frame, my data frame, and we use toExcel function and specify the path where we want to create our file. And at the end, we specify a file name to be created. The file name is mydataframe.xlsx. Let's run the code and see what the program created on my desktop. So you see it has created my data frame XLSX file. Let's open those to see the result. You see our initial data frame has been clearly exported to an Excel file. Here you see our initial data frame. It's exactly the same as in Excel file.